Now the next question is 26. Integration cos root x by root x dx. So here you will see that how to solve it. Now what I am going to do is here that let root x is equal to t. When you differentiate it, you should remember something, some types of technique here, that when you differentiate this half, when you differentiate it, you find that this comes of 1 by 2 x to the power of minus half, and this is equal to dt by dx. So 1 by 2 root x, that is equal to dt by dx, and dx by root x is equal to 2 dt. So this type of things you must remember, that when x to the power of, if you are differentiating x to the power of half, then after the result you will find that this root x which was in the numerator, it goes to the denominator. You must remember such type of things. Here you see root x, it was in the numerator, but what happened after differentiation? It became the denominator. So such type of techniques you must remember. So now here you see that this becomes 2 dt, and so it will 2 cos t dt. Now it has become easy for you to integrate it, and when you integrate it, you will get 2 sin t plus c and 2 sin root x plus c. This is your answer. Now I am going to question number 27. Here you see question number 27. 27. That is integration of root sine 2x cos 2x dx. So here this is easy. I will take sine 2x as t. So differentiation of sine 2x will become cos 2x, and I can easily solve it. But remember one thing, you can also select cos 2x, because differentiation of cos 2x is sine 2x. But the problem here is that this sine 2x, it is locked by the root. This sine 2x, it is locked by the root. So it will be better if you select sine 2x is equal to t, sine 2x is equal to t. When you differentiate it, you are going to get 2 cos 2x dx is equal to dt. You are going to get this. Now you place the values. When you place the values, you are going to get 1 by 2, that is root t, and this cos 2x dx, this becomes dt. So this will be 1 by 2 t to the power of half plus 1 by half plus 1 plus c. So this becomes how much? Half 3 by 2, 3 by 2, that means it will be 2 by 3, 3 by 2, 2 by 3, and t to the power of 3 by 2 plus c. So this cancel out 1 by 3, and your value of t is this sine 2x to the power of 3 by 2 plus c. So this is your answer. So this is your answer. Now my next question is 28. My next question is 28. Here you see 28. That is integration of cos x by root 1 plus sin x dx. This is very easy, because it is everything clear here, that if you take sin x, differentiation of sin x is cos x. So let 1 plus sin x is equal to t. When you differentiate it, differentiation of any constant is 0, and sin x, it comes out to be cos x dx, that is equal to dt. So dt by root t, this will comes out to be t to the power of minus half plus 1 by minus half plus 1 plus c. So this will be equal to root t by half, that is 2 plus c, because half 2 will come to the numerator, and this will be equal to 2 root value of t is 1 plus sin x, and this plus c. This is your answer. So when you do these questions, slowly it will become easier for you, and you will be able to find out which one will be better to select so that I can solve the problem. Now again here you see question number 29. Your question number 29, integration of cot x log sin x dx. So here, which would be better to select to take let? Now here, if I take log sin x, if I am taking log sin x, let log sin x is equal to t. Now here we are going to apply chain rule in differentiation. We are going to apply chain rule. When I apply chain rule, then the differentiation of log sin x will be 1 by sin x, and differentiation of sin x will be cos x dx is equal to dt. So cos x by sin x, it is cot x, so it will be cot x dx is equal to dt. So here see, cot x is available to you, and the integration now becomes very easy. So this will be cot x, and this log sin x, it has been considered as t. So cot x dx, this is dt. So this comes out to be t square by 2 plus c. So this will be equal to log sin x the whole square by 2 plus c. So this is your answer. So this becomes your answer. So when you do the sums, when you go on doing the sum, you will be easily able to know which would be the right supposition, so that integration can be possible. Now my next question is here everything is sin x and cot x dx, that is dx. My next question 29:30. Question number 30, you see here. Question number 30, that is integration of sin x by 1 plus cos x dx. This is the integration. This is also easy, because you know that if I suppose cos x, then differentiation of cos x is sin x, which is available in the numerator. So let us take 1 plus cos x is equal to t. When I differentiate it, the differentiation of constant is 0, and cos x is minus sin x dx, that is equal to dt. So sin x dx, that is equal to minus dt. Now I am going to put the value of this. So when I put the value of this sin x dx, that is minus dt, and here t. So I have told you earlier that if the differentiation of the denominator is present in the numerator, if the differentiation of denominator is present in the numerator, then your answer is log of the denominator, which will be equal to minus log t plus c, that is equal to minus log 1 plus cos x plus c. This is your answer. So in this way you can solve the questions. Now let me see the answer of 7.2, that is 30, because 7.2 question number 30, it is 1 plus cos x, and you mind it is in the answer. These are given because these are given like this. Log, always log is expressed in modulus 1 plus cos x it is always expressed in modulus. Why? Because log negative does not exist. Always log of positive numbers are taken. So it has been given a modulus sign. It doesn't matter whether you write it or not, everything is correct. Now, my next question is 31. My next question is 31. Here you see, my next question is 31 question. That is 31. Here, integration of sin x by 1 plus cos x, the whole square dx. Here again, the same thing, everything is known to you, that if you suppose cot x, here let 1 plus cos x is equal to t. If you suppose this, then when you differentiate it, constant is 0, cos x is minus sin x, cos x it is minus sin x. So now I am going to differentiate it. When I differentiate it, we are going to differentiate it. So here you will see this. That is, constant is 0, cos x is minus sin x dx is equal to dt. So sin x dx is equal to minus dt. Now you put the value here, minus dt by t square, that is equal to minus t to the power of minus 2 dt, which comes out to be minus 2 plus 1 by minus 2 plus 1 plus c. So this is minus plus, so 1 by t plus c. So this comes about 1 by t, that is 1 plus cos x plus c. This is your answer. This is your answer. Now I am going to question number 32. Question number 32. Here you see question number 32. Question number 32. That is integration of 1 by 1 plus cot x dx. This is 32. So how you are going to solve this? 1 by 1 plus cot x. How you are going to solve this? To solve it, let us take 1 by 1 plus, what is cot x? That is cos x by sin x dx. So LCM will be here your sin x and sin x plus cos x. This is 1 by dx. So this comes out to be like this, sin x by sin x plus cos x dx. This comes out like this. So now again there is a point here that if you take this, if you suppose the denominator, then sin x is cos x is minus sin x, which is not available in the numerator. Some manipulations I am going to do here, that is 1 by 2 into 2. Now what I am going to do here is that you see that is 1 by 2 integration sin x plus cos x, again plus sin x minus cos x divided by sin x plus cos x dx. I am going to do this here. You see this. See, cos x cancel out, and sin x plus sin x, 2 sin x, 2 cancel out. So the question, there is no alteration in the question. Question remains as it was. Now by doing such adjustment, it has been helpful for me to integrate it. So what I am going to do here, I am going to divide the LCM into 2 parts, that is 1 by 2. First part is integration sin x plus cos x by sin x plus cos x dx, and the other part is, that is sin x minus cos x by sin x plus cos x dx. I have divided this, means I have made the 2 parts, the denominator, I have made this denominator into 2 parts. have adjusted like this. So what happens to me, that this and this cancel out, so this will become 1 by 2 and this is only dx and this part remains. Now if you see clearly, if you suppose this sin x plus cos x, if you suppose this as t, then differentiation of cos x is sin x is cos x and that of the cos x is minus sin x. That means, let me do to you for this part integration, this remains like this, cos x by sin x plus cos x dx. This is u. Now for this part I am going to do here for you. For this part, here you see that if I take your sin x plus cos x is equal to t, I am going to do the integration only of this section, sin x minus cos x by sin x plus cos x dx. If you take this, let sin x plus cos x is equal to t, then differentiation of sin x is cos x and that of cos x is minus sin x and dx, that is equal to dt. Now if I take minus common from here, so this becomes sin x minus cos x dx, that is equal to dt. So sin x minus cos x, that is dx, that is equal to minus dt. So here you see that the numerator it becomes minus dt and the denominator is t. So this becomes minus log t. So this is equal to minus log, the value of t is sin x plus cos x. So what I am going to do here, that I am going to put the value of, directly going to put the value of this here. So your answer results out to be 1 by 2 integration, this is this, minus, this is minus log sin x plus cos x closed and plus c. So this is your answer. So I think so this is clear for you. Now I am going to the next question, and that is the 33 question. It is also of the similar type which I have done now. It is of the similar type. Going to question number 33. Question number 33. Here you see that again integration of dx by 1 minus 10x. Again I am going to do the same pattern, that is in dx by 1 minus sin x by cos x. If you are going to take the LCM, this will be equal to, here this is your LCM, cos x minus sin x, and here this is 1 dx. So cos x will come to the numerator and this will be cos x by cos x minus sin x dx. And again this question is of the same pattern as I have done just earlier. So what I am going to do is 1 by 2 into 2. So now I can write like this, equal to 1 by 2, that is cos x minus sin x, and again cos x plus sin x divided by cos x minus sin x. I can write like this. You can see here, it is, everything is clear. You can see here, that is sin x cancel out, and cos x plus cos x is 2 cos x. So there is no change in the question. So I can do it. Now I am going to divide this LCM. Now divide this LCM, giving making it into two parts, that is cos x minus sin x by cos x minus sin x dx, and plus that is cos x minus plus sin x by cos x minus sin x dx. Now here you can see clearly that this and this cancels out. Now if I take this as, let's suppose this as t, so differentiation of cos x is minus sin x, and sin x is minus sin x is cos x. I am going to get the numerator. Only I have to do is the taking minus as the common. So I am doing in a shortcut instead of here. Let me do it again for you. Now for this 1 by 2, this will be the dx, and cos x plus sin x by cos x minus sin x dx. Now here I am going to do this part here. So this will be integration cos x plus sin x by cos x minus sin x dx. Now if I suppose this, so let cos x minus sin x is equal to t. When I differentiate it, you are going to get minus sin x minus cos x dx is equal to dt. Now if I take minus common here, so minus sin x plus cos x, and that is dx, that is equal to dt. So sin x plus cos x, that is dx, that is equal to minus dt. So here you see the numerator becomes minus dt by t. So this will be equal to minus log t. So this will be equal to minus log, that is cos x minus sin x. So now I am going to put the value of here. So this will be equal to 1 by 2, that is equal to x minus log, this will be cos x minus sin x and plus c. So this is your answer. Now question number 34. Here question number 34, here you will see that, 1 minute, question number 34, that is integration of root 10x by sin x cos x dx. So how to solve it? Now I am going to do one thing here, that if I, let us see, root 10x means sin x by cos x, and this is a sin x cos x dx. So here this will come out to be root sin x and sin x. Now this root cos x into cos x dx. So this will become instead of doing this, let us take the help of sec square x, sec x, that is sec x. What I am going to do here, root 10x, now sin x by cos x, this cos x is earlier in the question, let cos x dx. See here, this sin x, here I have divided by cos x and multiplied by cos x, and this cos x is originally in the question. When there is 10x, it is better that you go for sec x, because you know that if sec square x is present, then we can integrate it easily. So that is the helpline I am going to take here. So 10x, and this will be equal to 10x sin x by cos x, and this is cos square x dx. So here cos square x, it will be converted into sec square x, and half and 1, so this ultimately becomes sec square x by root 10x dx. The question has been converted to in this form. Now this becomes easier for me to solve it, because if I suppose 10x, then differentiation of 10x is sec square x. So let 10x, that is equal to 10x is equal to t. So differentiating it, we get sec square x dx, that is dt. So if I place here, this becomes dt by root t. Now it is easy to solve it. So here you see this will be t to the power of minus half dt. So t to the power of minus half plus 1 by minus half plus 1 plus c. So this is equal to root t by half, that is 2 plus c. So this will come out to 2 root. Your t is 10x plus c. So this is your answer. Now I am going to the next question, that is question number 35. Question number 35 here. Question number 35. Question number 35, here you see that 35, 1 plus log x the whole square by x dx. Here what you do is that I am going to suppose 1 plus log x, because you know that differentiation of log x is 1 by x. So let 1 plus log x is equal to t. When you differentiate it, 1 by x dx is equal to dt. Here this is clear for you. So this becomes t square dt. So this is a t to the power of 3 by 3 plus c, and value of t is 1 plus log x to the power of 3 by 3 plus c. So this is your answer. So now question number 36. Here question number 36. In question number 36, it is given to you 36, that is x plus 1 x plus log x the whole square by x. You have to integrate it. Now you see one thing. If I take x plus log x, I am going to get this. Such type of idea you will get when you go on solving the problem. You will get this idea, because by looking into the question, I am able to assess that if I suppose this x plus log x is equal to t, I am going to get this value. Because you know that differentiation of x is 1 and differentiation of log x is 1 by x. And if you take the LCM, then it comes out to be this comes out to be this. So see here, what I am going to do, let x plus log x is equal to t. Now when I differentiate it, 1 plus 1 by x is equal to dt by dx. So this is x plus 1 by x dx, that is equal to dt. So here you see x plus 1 by x dx, that is dt. So this comes out to be t square dt. So this is t to the power of 3 by 3 plus c. So value of t is x plus log x to the power 3 by 3 plus c. So this is your answer. So this is your answer. Now my next question is 37, question number 37. Here question number 37. Here we will see that I am going to remove this x cube. To remove this x cube, I am going to suppose let x4 is equal to t 4x to the power of 3 dx is equal to dt. So x cube dx, that is equal to dt by 4. Now your question reduces to here sine tan inverse t divided by 1 plus t square and dt by 4, that means 1 by 4. Now the second part is that again I have to suppose this tan inverse t. So let tan inverse t, that is equal to m. When I differentiate it, I am going to get 1 by 1 plus t square dt is equal to dm. So here this will come out to be 1 by 4 sine m by sine m into dm. Now when I integrate this, this is integration of 1 by 4 sine, this is sine m dm. So 1 by 4, this is integration of sine, it is minus cos m plus c. So minus 1 by 4 cos m, that is tan inverse x to the power of 4 plus c. This is your answer. So let me check the answer of 37, 7.2, 7.237, 7.2, 7. Minus 1 by 4, it is correct. So this is 37. Next question is 38. Now I am going to 38, question number 38. Question number 38. 38 here. 38. The question is integration of 10 x to the power of 9 plus 10 to the power of x log base e10 dx by x to the power of 10 plus 10 to the power of x. So here I want to say something that I will suppose this because it is clear here. If you take this as t, differentiation of x to the power of 10 is 10x to the power of 9 and differentiation of 10 to the power of x is this one. How differentiation of this is this, I will show you. So for this, y is equal to 10 to the power of x. You differentiate, you have, for this you have to take log y. Log y is equal to log 10 to the power of x. So log y is equal to this base e, x log 10 e. Now when you differentiate it, you are going to, I am going to apply chain rule, 1 by y dy by dx, that is equal to x log differentiation of this, sorry, 10, this is 10, log 10 base e is considered as 1 as constant, so this is 1, so this becomes log 10 e. So dy by dx is equal to y log 10 base e, this is base e. So what is the value of y? 10 to the power of x log 10 base e. So here you see that if you differentiate this, you are going to get this. So it's okay now. So it is clear here. If you suppose this x to the power of 10 plus 10 to the power of x has t, you are going to get the numerator. And you know that if the differentiation of the denominator is present in the numerator, then the answer is the log of the denominator. So this becomes log x to the power of 10 plus 10 to the power of x plus c. So this is your answer, comes out to be this. So let me check the answer 38, which is 7.238. 7.2 38, it is D, so answer is D. Now your last question of this exercise, the last question of this exercise it is the last question of this exercise, that is 39. This is the last question of this exercise. Integration dx sine square x cos square x dx. You always remember, if there is such type of questions, you always remember, if there is such type of question, you always go for tan and sec. You always go for tan and sec. So I am converting this to 10 nsec, that is how sine square x divided by cos square x into cos square x into, this is the original cos square x, this I have divided and multiplied it. So what becomes here, so dx by this becomes 10 square x, and this is cos 4x, that is it becomes sec 4x. So this becomes sec 4x by 10 square x dx. This becomes, now I am going to do little bit adjustment, that is nothing very tough adjustment. Sec square x into sec square x, instead of sec 4x I am going to write like this, and 10 square x ds. Why you will, it will be clear for you, that is, and instead of sec square x I am going to write 1 plus 10 square x, and that is sec square x and then 10 square x dx. Why I am going to have written like this in sec square? Now you suppose, let 10x is equal to t. When you differentiate it, it becomes sec square x dx, that is equal to dt. So here sec square x, that is dt, and so this becomes 1 plus t square by t square dt dt. Now you can what I am going to do this next is that here you see 1 by t square dt plus dt dt. So this is t to the power of minus 2 plus 1 minus 2 plus 1 plus t plus c. So this will be t to the power of minus 1 by minus 1 plus t plus c. So minus 1 by t plus t plus c. So what I have supposed 10, so minus 1 by 10 x plus 10x plus c. So this is your answer. So here as per you can write like this, 1 by 10x as minus cot x plus 10x plus c. So you can also write as 10x minus cot x plus c. So this is your answer. So this is all about this exercise. It has been completed now, and x 7.4 it has been completed now.